Hi class, welcome to the session on rehabilitation engineering. Now that we have completed our unit 1, let us move on to the second unit, which is principles of rehabilitation. So in this unit, we're going to have an introduction like every other unit. Then we are going to discuss the human component, principles of assistive technology assessment, principles of rehabilitation engineering, which includes the key engineering principles and key ergonomic principles, and practice of rehabilitation and assistive technology. So in today's session, we are going to just discuss the introduction. So let's crack on with the lecture. So two terms that popularly, uh, you know, that we popularly encounter are rehabilitation engineering and assistive technology. Now, these two terms are often used synonymously. However, there's a subtle difference between the two. Now, James Reswick, who is a pioneer in rehabilitation engineering, has defined rehabilitation engineering as the application of science and technology to ameliorate the handicap of individuals with disability. Now, ameliorate means to reduce the handicap of individuals with disability. So, it's any science and technology that does that is rehabilitation engineering, according to James. Now, assistive technology is the product of rehabilitation engineering. So, in order to ameliorate the handicap, you take the help of certain technological devices, or it could just be a software. So, all these are assistive technology, and it can be defined as any item, piece of product system, whether acquired commercially off the shelf, modified or customized, that is used to improve or increase the functional capabilities of individual with disability. So any product or any system or any software that can be customized or that can be used as such to improve the functional capability of an individual with disability is an assistive technology. So why are there so many definitions, right? Why can't they just give us one crisp definition and say like, there you go, that is assistive technology and this is rehabilitation engineering? It's because these techniques have been used for quite some time. They've been used for decades together. And over the period of time, as technological advances are encountered, these terms have undergone certain changes. Like there are certain inclusions and exclusions, and because of which we have so many definitions. So if we just scratch on the history slightly, then we can see that during the World War II, many war veterans ended up being amputees, and there were very, very few trained personnel to assist them. So, because during the war there were like mass amputees, and there were very few people who were actually skilled enough to assist these war veterans and try to make their life as normal as possible. Now, also the availability of prosthetics during that period of time had very limited these prosthetics had very limited functions, and they were very uncomfortable to use as well. So the US Veterans Administration established the Veterans Administration Prosthetic Research Board, which facilitated the development and research of better devices. So now that money and manpower has been invested, the result was the development of lightweighted and cosmetically more appealing prostheses. So earlier, it was evident that this person was an amputee because of the kind of assistive devices that they used. So, as time progressed, these devices became more lightweight. Devices became more aesthetically and cosmetically appealing. So they were like resembling the normal arm as much as possible. So the federal government, which is the American government, provided generous funding to researchers who explored the use of modern sophisticated technology for improving the prosthetic device. So anyone who was interested in using technology to improve the performance of a prosthetic device was highly encouraged and funded by the US government. Apologies for this. It's just So in 1973, the Federal Rehabilitation Act was passed, which resulted in the recognition of rehabilitation engineering as a formal engineering discipline. So this resulted in the formation of the National Institute on Disability and Rehabilitation Research, the NIDRR, which supervised the rehabilitation engineering centers. So now this can be compared with the relationship between a teacher and a student. So the teacher teaches the student, the head of the department monitors the performance of the teacher monitors the performance of the student, the head of the department monitors the performance of the teacher, and the principal monitors the performance of the head of the department. So you require a governing body that's keeping an eye on you while you are rehabilitating people, and that's what NIDRR did. So RECs initially supported only university-based research because they thought that universities are the ones that are developing devices that will be used. However, later on, they broadened their horizons by including technology transfer and service delivery as well. So this enabled people to actually sell the product if it was good enough and if it was helping the desired, the intended patient population, then the RECs supported them to market the device and sell it. So in 1979, the Rehabilitation Engineering Society of America, the RESNA, was formed, and this concentrated on the development, manufacture, provision, and usage of technology to improve the quality of life of a disabled person. The Rehab Act of 1986 and the Technology Related Assistance Act of 1988 addressed that there was shortage of rehabilitation engineers who were suitably trained and experienced, and also these laws they made it mandatory that every disabled person would get a rehabilitation service, and this service would be funded. So the need for individualized work and rehabilitation plan was also emphasized in these laws. That means that they acknowledge the fact that rehabilitation program or regime should be customized according to the individual's requirement. So here are some pictures. The top right is a prosthetic arm that was that was used in the early days, the 1960s and 70s, and same is the top right leg, which is like the wooden leg as it was called. Now in the bottom left you can see a robotic arm which has most of the dexterity of the human arm. So now these devices, they are smart enough to capture the EMG signal from the stumps or the nerve stumps that are available from amputation, and they can actually read and interpret the brain signal and perform the task accordingly. And the bottom right is the famous blade leg or blade limbs that are used by Paralympians to, participate in sprinting. And it's a revolution, I'd say, from from the wooden leg to be able to produce prosthetic limbs that would enable a person to not only to walk properly but actually to sprint and run. I think that's all we have in today's session. I hope you had a wonderful time studying rehabilitation engineering with me. I shall see you again with another video soon. Thank you very much.